Hi student. So today let us move to the first topic of your class 12th, that is nothing but a inverse trigonometric function. So inverse trigonometric function, this is one of the smallest topic or the smallest chapter in your class 12th. So this chapter is also one of the easiest chapter, I can say it. Suppose if your basics regarding the trigonometric functions which you have already learnt in the class 11th, that basic concept regarding the trigonometric function that is strong means, then some of the basic concept regarding the relations and functions, if those two are strong means, then this is one of the easiest chapter I can say to you peoples. So now let us go to the concepts of inverse trigonometric function. So first of all I will deal with what is function. So already you have learned the definitions of the functions in your previous class also and in the previous chapter also, that is what is the definitions of the function. So what does it say? A special relation is called as a function if no two ordered pair is having same first element. So such a special relation is called as a what? Function. Suppose if I considered a mapping means, a mapping of this format is not at all a function, because here this is having the two images. Another definition of the function is saying what? Each element in the domain is having a unique image in the codomain. So that is another definition of the function. But here this element is having two images, so it is not at all a function. But like this type of a function or a mapping can exist, that is two elements can have the same element as an image. So this type of mapping can exist, but this type of mapping cannot be existed in the function. So this is the basic or the definition of a function. Then it comes to the trigonometric functions. So we all know that the trigonometric ratios like sine, cos, tan, cot, cosecant and secant, all these 6 trigonometric ratios, this satisfies the conditions, it satisfies the conditions of the function. Since it is satisfying the conditions of the functions, all this trigonometric ratio has become what? A trigonometric functions. Because suppose if we consider any angle and give it input that angle for any of the functions, suppose if I input angle 30 to the trigonometric function sine means, we are going to get one particular value in the codomain, that is nothing but 1/2. So it is satisfying the terminology of a functions. So this trigonometric ratio is considered as a trigonometric function. In detail regarding the trigonometric function you have studied in the class 11th. Suppose if you didn't brush up with the trigonometric function means, please brush up some of the basic concepts regarding the trigonometric functions. Okay, and here what we are talking, inverse of that functions. So we have already came across the inverse function. So what is that inverse function is saying? Suppose a function is said to be, if suppose a function is said to be invertible means, then the inverse of that function is going to be existed. So when do we call a function is invertible? When a function is bijective means, then we call that function is invertible. When we call that function is bijective, when that function is both 1 1 and on 2 means, then we call that function is as bijective. Suppose function is bijective means what? Then it is invertible. Then it is invertible means what? Inverse of the function is going to be existed. Suppose inverse exists means, then we can find the inverse of that function. So what is the major condition to find the inverse of the function is this one. That is, the function should be the bijective function. So now to say any function is having a inverse function means this is the basic thing, that is the function should be a bijective function. So now since we are talking about the inverse trigonometric function, these are the 6 trigonometric functions. Now let us consider a sine function and check whether the sine function is what, whether the sine function is bijective or not. Let us check it once. Okay, so what is the domain and range of the sine function? So the sine function, it is defined from the set of real numbers. Since the input of a sine is an angle, then what about this real numbers? So we know that angles in radian is considered as what? It is considered as set of real numbers only. So since we are inputting the angles in terms of radian, the domain is set of real numbers. So if we input the angles in radians from the set of real numbers, its range is what? Its range is limited to -1 to 1. So this is the domain and range which we commonly know for the sine function. So what happens? Sin x is equal to y. If we input any angle means we are going to get one value which is lying within the range -1 to 1. So now let us understand whether the sine function is a bijective or not with the terms of both mapping as well as in the terms of graph. So if I considered here mapping, that is mapping is here, graph is here, so I'll explain you the bijective of a function in both of these terms also. So this is a graph of what? Sine function, that is sin x is equal to y. So now let us first look into for 1 condition. 1 condition. So this is a sine function. So suppose, what is the basic condition for 1 function? What is the basic condition for 1 function? If f of x1 is equal to f of x2 means this implies what? x1 is equal to x2. Suppose if I considered here in the sine function, that is f of x1 is equal to f of x2. So what is f of x1 and what is f of x2? That is sin x1 is equal to, here because the function is sine, right? So sin x1 is equal to sin x2. But suppose if I take f of x1 is equal to f of x2 is equal to 1. So sin x1 is equal to sin x2. But this does not imply x1 is equal to x2, because if I take x1 is equal to pi by 2 and x2 is equal to 5 pi by 2 means, you can observe here, when it is pi by 2 the value of sin is 1, when it is 5 pi by 2 the value of sin x is sin 5 pi by 2, it is also 1. So clearly sin pi by 2 is equal to 1 and sin 5 pi by 2 is also equal to 1. So f of x1 is equal to f of x2 here, but this does not imply that x1 is equal to x2, that is pi by 2 is not equal to 5 pi by 2. Both are the different angles, so it is not an a 1 function. So I explained it is not an a 1 function in terms of our writing way. Suppose by looking into graph only you can say here. So this one, since this is the x-axis, so whatever the values here we are taking, it becomes what? Small x. Y-axis becomes the function of sin x. So whatever the value we are going to get here, it is nothing but y. So or y, that is nothing but f of x. So suppose if I take here pi by 2 and 5 pi by 2 means, you can observe here clearly, that is both are having what? Both are having the same value, that is 1. So 5 pi by 2 and pi by 2 and 5 pi by 2 both are having what? Same value of that function sin x. So it is not an a 1 function. Suppose you can see here in terms of mapping also, mapping. Here this is our domain, and this is domain. Here the angle is set of real numbers, and here the range is, it is lying from -1 to 1. There are infinitely many real numbers here. You can observe here clearly, when it is sin phi by 2, it is 1, and when it is sin phi pi by 2 also, it is 1. So when we say the mapping is 1 1, for each value there should be one and only one image. But here you can see here pi by 2 and phi pi by 2 both are having the same value or same image, that is 1. So it is not an 1 1 function. So it is not an 1 1. Suppose if you consider it in the terms of this one, that is from 0 to pi itself, if you consider, means you can see here this one and this one are two different values, x1 and x2, but you can see here both x1 and x2 are having what? Same f of x here, because f of x1 is also this point only, and f of x2 is also what? This point is also same. F of x2 is also the same point only. So both the values x1 and x2 are having what? Same images, that is f of x here at this point. So sine function, it is not 1 1 function. It is not an 1 1 function. Suppose if we talk about an onto condition, you can take, when we talk about onto means our concentration is upon the what? Our concentration is upon the codomain, that is the range value lying from -1 to 1. So all these values, if we take any value, since there are infinitely many values lying from -1 to 1, here I have represented only few. So all these, if you take any point from this range from -1 to 1, means you are having any one particular angle. You can observe that one in the graph itself. So values lying from 1 to -1 are this one. So if you take any point ranging from 1 to -1, and if you move, means you are going to get any corresponding value for the x. If you take this point, if you take the move along with that graph, means you are having any one particular value of x. If you take any one point here, move along any side, you are having one particular value x. So whatever the value you are taking from 1 to -1, there is a value of x lying within the graph. So the function is, that is the sine function is not 1 1, but it is an onto function. So it is not 1 1, but onto function means clearly what? Sine function, it is not a bijective function. It is not at all a bijective function. So here I talked about the sine. You can verify like that only for cos, tan, cot, any of the function also, means you can observe the same thing. All these functions become the onto function, but those are not an whatever, it is not going to become a 1 1 function. So here the question arises, how we are talking about the inverse of those trigonometric function when those trigonometric functions are not at all a bijective function. So this is the concept where the inverse trigonometric concept arises, how we are going to study the inverse trigonometric function when the trigonometric functions are not at all a bijective functions, that is it is not at all a 1 1 function, means how we are talking about the inverse of those functions. So inverse of these trigonometric functions we are going to talk, means the thing is it should be a bijective. So our first agenda is to make the trigonometric functions as what? Bijective function. So first we need to turn those trigonometric functions into bijective functions. Once it turns into a bijective, means then we can talk about the inverse of those functions. So how we are turning these trigonometric functions into a bijective functions? By restricting the domain of the trigonometric functions, by restricting the domain. So by restricting the domain of the trigonometric functions, we are turning those trigonometric functions into a bijective functions. Once the trigonometric functions turns into a bijective functions, then we can talk about the inverse of those functions. So how we are restricting the domain means, so here the domain is set of real numbers, so whole real numbers are there. Suppose if I restrict the domain of the sine function from minus pi by 2 to pi by 2, that is from here to here, at that time what is the graph of sine function? Only this much, only this much. So let us talk about details how we are restricting the domains of each and every trigonometric functions. By restricting, how it turns into a bijective functions. So let us talk about those things in detail one by one. So this is a basic or the initial information regarding the inverse trigonometric function. So how this inverse trigonometric function is going to be existed, or how we are going to talk about the inverse trigonometric function. So this is a foundation or a basic thing how the inverse trigonometric function is going to be existed. So now let us talk about each trigonometric functions or the inverse of each trigonometric functions one by one. So before going to talk about the inverse trigonometric functions of each of the trigonometric functions, so now let us know what are the domain and the range of each and every trigonometric function. So when it comes to the sine function, our domain is what? It is the set of real numbers. So what is the range of this sine function? It is lying from -1 to 1. Then similarly, what is the domain of the cos function? It is also set of real numbers, and the values of the cos function, it is ranging from -1 to 1. What about the tan function? So when it comes to the graph of the tan function, means the graphs are like this, something like this. So clearly we know that the functions are not defined at the point pi by 2 and the multiple angles of pi by 2. So how our domain will be? From the set of real numbers at multiple angles of pi by 2, tan function is not at all defined. So from the set of real numbers, I am removing those multiple angles of pi by 2. That is, from the set of real numbers, minus x such that x is equal to 2n plus 1 pi by 2, where n belongs to the integers. So this becomes what? Multiple angles of pi by 2. So at that point the tan function is not at all defined. So from the set of real numbers I am removing those multiple angles of pi by 2. So this becomes the domain of tan function. So what is the range of the tan function? So range is nothing but again the set of real numbers, because here the function is defined from the whole set of real numbers. So similarly, cot function graph is similar to the tan function, but when it comes to cot, the angles are not defined at the multiple angles of pi. So from the domain, that is from the set of real numbers, I am removing those multiple angles of pi, that is x such that x is equal to n pi, where n belongs to the integers. So from the set of real numbers I am removing all those angles at which the cot is not defined. So at which angles? At the multiple angles of pi, the cot function is not defined. So from the set of real numbers I removed those angles. So this becomes the domain of the cot function. Then what is the range of the cot function? It is the set of real numbers. Now similarly, what about the secant function? Secant function means it is nothing but 1 by cos. So cos function means it is from the set of real numbers to -1 to 1. So it becomes the ulta of the cos function. So secant function means what happens? The function, it is defined from set of real numbers to at which point the secant function is not defined? At the multiple angles of pi by 2. So I am removing those angles. X is equal to 2n plus 1 pi by 2, where n belongs to set of integers. So from that point to from the set of real numbers, I am removing those points where the secant function is not defined. Then what is the range of this function? Range is set of real numbers. From this real numbers, these intervals are removed where the cos function is defined, because at those point the cos function, it is 1 by cos. So at this point the secant function is not defined. So that is nothing but r minus 1 to 1, where minus 1 and 1 are included. That's why closed interval. So minus 1 and 1. So the points which are lying between minus 1 and 1 are not at all in the range of the secant function. Similarly, for cosecant function, the domain is from the set of real numbers, the multiple angles of pi. It is not at all included in the domain of the cosecant function. So I am removing those points, and the function, it is defined, or the range of this cosecant function, it is again r minus 1 to 1. It is a closed interval where minus 1 and 1 are included in the cosecant function, but the points which are lying between these two points are not at all included in the cosecant function. So this becomes the range of this function. So now these are the domain and range of what? Trigonometric functions. Trigonometric functions. So now we are talking about the inverse trigonometric functions of all these trigonometric functions. To know the inverse, this knowing about the domain and range of each trigonometric function is must and should. That's why I have gone with the domain and range of each trigonometric function. And another thing is inverse. So inverse definition, as usual, I have said in the previous point itself. But we know that if a function f from set x to y is defined and this function is bijective, suppose a function f from x to y is defined and that function is a bijective function, means then there exists a function g from y to x, then there exists a function g from y to x, where that g is nothing but what? It becomes the inverse of that function, inverse of the function f, that is g is equal to f inverse. So this is the thing which we have learnt in the chapter 1 of relations and functions. Suppose the function is bijective, means then there exists a function g from y to x, and that is satisfying the two conditions, that is gauge of x is equal to x and fog of y is equal to y. So then that function is called as what? Inverse of that function, that is g is equal to f inverse. So this is the definition of the function we have came across. So now we are following the same rule to find the inverse of each and every trigonometric functions. So now let us talk about the inverse of the sine function. So clearly the sine function is defined from set of real numbers to minus 1 to 1, and the graph of the sine function is something like this. So I have drawn the graph of sine function roughly. So this is the graph of the sine function, and clearly it is not a 1-1 function, because suppose if I talk about any two x1s lying here also, means so this one is x1 and this one is x2. For these 2 points they are having what? They are having what? Same f of x1, that is same point. For at this point also we are going to get the same f of x1, and this point is also same f of x2. Clearly at this x1 and x2, f of x1 is equal to f of x2, but x1 is not equal to x2. So clearly with this graph it is not a 1-1 function, but it is an onto function. So now how we are turning that sine function? So it is not a bijective function. Now here it is not a bijective function. Now I need to turn this sine function into what? Bijective function. Clearly it is an onto function, but now I need to turn that sine function into 1-1 function. So it can be made bijective by restricting its restricting its domain. Suppose, so here this one is 0, here this becomes pi by 2, this is pi, this is 2 pi, and this is 3 pi. Suppose if I restrict the domain from 0 to 2 pi, that is from here to here, the graph becomes what? Only this much. So when I restrict from 0 to 2 pi means the graph of the function is from here to here only. The dark thing, I hope you can understand with this diagram. Even if I can restrict from 0 to 2 pi also means it is not a 1 function, because you can see the same points like this. There are many points in this function which is having for two different values. We are having the same values of f of x1. Suppose if I restrict from 0 to pi, at that time what the graph becomes? Suppose if I restrict from 0 to pi means only this much. Here it is 0, it is pi. Again at this point also we can observe the same thing, that is at two different points we are having the same f of x1. So restricting from 0 to pi also does not make the sine function as a 1 function. So now we are restricting the domain of the sine function from where this is our pi by 2 and this is our minus pi by 2. So I am restricting the domain of the function from minus pi by 2 to pi by 2. So suppose this is pi and this is minus pi, means this becomes minus pi by 2 and this becomes pi by 2. From 0 to pi by 2, how the graph is? From 0 to pi by 2 up to here, it is like this. So from 0 to pi by 2, the graph is like this. From 0 to minus pi by 2, it is like this. So 0 to minus pi by 2, it is like this. So clearly when it say from minus pi by 2 pi by 2, the graph of the sine function is clearly like this. So now if you take any point between minus pi by 2 pi by 2, if you take any point lying between minus pi by 2 pi by 2, for one point or for one value of x, there is only one f of x which is lying in the range of that function. So you can see here, I took here one value, for that value there is only one f of x. Suppose if you take another x, means we are going to get only one values in the range. Suppose if you take another value from the negative side of, that is from 0 to minus pi by 2 also, means you are going to get only one value in the range of that function. So each value, for each value of x which is lying in the domain, that is from minus pi by 2 pi by 2, we are going to get the one and only one image in the range of that function. The range is from minus 1 to 1 itself. So range is not at all altered. This is minus 1 and this is plus 1 itself. From minus 1 to plus 1 range, if you take any values lying between minus pi by 2 pi by 2 means, then we are going to get only one image in this range. So by restricting the domain, by restricting the domain from minus pi by 2 to pi by 2, the sine function's domain from minus pi by 2 pi by 2, the range is same, from that is minus 1 to 1. The sine function became what? This function became what? It is now 1 function, because for each value of x there is one and only one image, and clearly the sine function was onto. So by restricting from the set of real numbers to this restriction, we got the sine function has what? Has a bijective function. Now this function is bijective, means now there exists a inverse function. Now there exists the inverse of this function, inverse of this sine function. So that is nothing but sine inverse. So as I said in the beginning, if f from x to y is an bijective, means then there exists a function g from y to x, where the domain of that inverse function is nothing but the codomain of the function f, and codomain of the inverse function is the domain of the function f. So here f function is nothing but sine, so the inverse function g is nothing but sine inverse. So what is the domain of this now sine inverse? It is nothing but -1 to 1, and the codomain is nothing but minus pi by 2 to pi by 2. So this is nothing but the inverse of the sine function, where domain is -1 to 1 and our range is nothing but minus pi by 2, pi by 2. The thing now, one of the important question which you people might arise is, here we have restricted from minus pi by 2, pi by 2. Suppose if I restricted the domain from pi by 2 to at this point is nothing but 3 pi by 2. Suppose if I restricted the domain from pi by 2 to 3 pi by 2, at that time how the graph will be? Pi by 2 to pi, it will be like this, and from pi to 3 pi by 2 it will be like this. So at that time our graph is this one, when it is lying from pi by 2 to 3 pi by 2. So suppose if I restricted the domain from pi by 2 to 3 pi by 2, or else from pi by minus pi by 2 to minus 3 pi by 2, whatever the thing, if you restricted anything, if minus pi by 2 3 pi by 2 means at that time this part of the graph, all this time also we are going to get the 1 function only. Suppose the restriction is from pi by 2 to 3 pi by 2, then the range is again -1 to 1 itself. Suppose if you restricted from minus pi by 2 minus 3 pi by 2 also, means we are going to get the bijective function only. But why we have considered only this interval? If suppose this is the one of the question, suppose if you might have arise, means because it is the what we call this restriction or this range of the function or the restricted domain is called as what? Standard restriction or the standard value. When it is saying standard means all along the whole worldwide, this angle only considered as the standard restricted domain. That's why the standard restriction of the domain of a sine function is nothing but minus pi by 2 to pi by 2. That's why the sine inverse function, if we take, means -1 to 1 and minus pi by 2, pi by 2 becomes the range. That standard restricted domain here, range, when it comes to sine inverse, what the restricted domain in the sine function became, it is nothing but the range of the inverse trigonometric function, that is inverse of sine. This restricted or the standard range is called as principal value branch. Principal value branch. All these other branches, what we call as, these are called as different branches of inverse trigonometric function, but this branch, that is minus pi by 2 pi by 2, is called as a principal value branch. Whenever we say the sine inverse function, means its domain is this one and the range will be always principal value branch itself. It is a standard range which we are going to be considered. So this is regarding the how we are going to find the inverse of the sine function. Now let us similarly find the inverse of rest of the trigonometric functions. So now let us talk about the inverse of the cos function. So what is the cos function? Domain and range is saying the cos function definition is, it is a function whose domain is set of real numbers ranging from -1 to 1. So according to this definition of a cos function, this is the graph of the cos function, where x is the angles in terms of radian and y it is ranging from -1 to 1. So clearly by looking into the graph, we can say that again cos function is not a 1 function, because here if we take two values at the different points, means we are having the same value at respect to that points. If I consider these 2 points, means at these 2 points we are having the same values of y. So at x1 and x2 we are going to get at two different, where x1 is not equal to x2, we are going to get f of x1 is equal to f of x2. So this is again cos function at this range, it is not an 1 function. So clearly this is not a bijective function. So when this is not a bijective means, now we need to convert this cos function into a bijective function, means that is done by restricting the domain. So now how we are going to restrict the domain? So when it come into the sine function, means we restricted the domain from minus pi by 2 to pi by 2. Suppose if I consider again here from minus pi by 2 pi by 2, means this part of the graph is coming. Again this part if we consider from minus pi by 2 pi by 2, means again this is not an 1 function, because at two different values of x we are going to get same values of f of x1 and f of x2. So again this restricted domain is not valid, where the sine function where it is restricted, that restricted value is not valid for the cos function. So for the cos function, which is the restricted domain, now I need to consider. So I need to consider the restricted domain from 0 to pi. Suppose if this is a graph, x-axis, y-axis, 0 to this is pi by 2, and if this is pi, means from 0 to pi by 2, how it is the graph is, if this is 1 and this is minus 1, means 0 to pi by 2 it is from here to here, from pi by 2 to pi, means it is like this. So when I restricted the graph from 0 to pi, that is from 0 to pi angle, we got a graph in this manner. So this is nothing but what? At this graph, so at this graph, for each values of x, if you take any values, we are going to get one and only one image of that point. We are going to get one and only one image. If you consider any one point, means you are going to get one and only one image. Sorry, it will not come like this, it will be like this. So we are going to get one and only one image. So now when the cos function's domain is restricted from 0 to pi, means we are going to get like this graph. Similarly, not only from 0 to pi, suppose if I restricted from pi to 2 pi, at that time we are going to get only this part. Again this part is also, if we restricted from pi to 2 pi also, means that at that time also the cos function becomes the bijective, that is it becomes 1 function. Suppose if I restrict from 0 to minus pi, at that time we are going to get this part of the graph. At that time also it becomes the bijective function. So all those 0 to minus pi and pi to 2 pi, all these restrictions are the different branches of the inverse trigonometric function. So now cos function, when it is defined from, the domain of the cos, that is from set of real numbers to, it is restricted to 0 to pi, and the range is same -1 to 1, because clearly you can see here, if I take 1 to minus 1, in 0 to 2 pi, all the values of this graph is lying from 1 to minus 1 only. So there is no other extra points are adding to this points of x when it is lying from 0 to pi. So the range of the function remains same. At this time our cos function become bijective function. It become the bijective function. So once the cos function became the bijective function, now inverse of this function is going to be existed, and that is nothing but cos inverse. So the cos inverse, it is lying from -1 to 1, which is the range of that cos inverse, and the range of that cos inverse function, that is 0 to pi, where this 0 to pi range, it is called as principal value branch of cos inverse function, and the other different branches of cos inverse functions are 0 to minus pi, pi to 2 pi are the different branches of the cos inverse function, but the principal value branch of cos inverse function is 0 to pi. That means how the function will be cos inverse of any real values, that is 0.5 means the angle of this cos inverse of 0.5, that is nothing but 1 by 2. Cos inverse of 1 by 2, that angle should be lying between 0 to pi. So which is that 0 to pi means it is nothing but obviously pi by, not pi by 2, it is 0. So like this the thing is going to be happen. The problem based upon this one, let us understand it later. So one hint how the domain is going to be played and how the codomain role is going to be, or the range of that function is going to be played. For that one I have showed these two examples. So this is how the principal, this is the principal value branch of the cos inverse function. Finally, after finishing all the finding the inverse functions of all the trigonometric function, let us make the table of domain and principal value branch of each and every inverse trigonometric functions, because in the inverse trigonometric functions the domain of each inverse function and principal value branch of each inverse trigonometric function is very important, along with the definition of inverse trigonometric function. So this is regarding the inverse of the cos function, that is we got the domain and range of the cos inverse function. Next is inverse of the tan function. So what is tan function? So we know that tan x is equal to what? Sin x by cos x. So sin x by cos x, where in the denominator cos x comes, means we know that the function is not defined when the denominator is equal to 0. So at what point the cos values are equal to 0? At the multiple angles of pi by 2, we know that cos values are 0, that is cos pi by 2 is 0, cos 3 pi by 2 is equal to 0, cos 5 pi by 2 is equal to 0, cos minus 3 pi by 2 is equal to 0, cos minus 5. So at all these points the cos function is 0. So when cos function is 0 means what? At all these points, that is the multiple angles of pi by 2, at all those multiple angles of pi by 2, the tan function becomes something by 0, that is infinity, which is not at all defined. So at the multiple angles of pi by 2, the tan function is what? It is not defined. So it is not defined means clearly what? We are removing those multiple angles of pi by 2 from the domain. That is, we are considering the angles from the set of real numbers, that is from the set of all angles in terms of radians. So from that real numbers I am removing all those multiple angles of pi by 2 where the tan function is not defined. So now this becomes the domain of the tan function. And range, here range you can see that the set of all real numbers which are lying in the y-axis becomes the range of the function. Now you can observe here clearly, when the tan function is defined like this, we can observe here at two different points. If I consider this point and this point, where this is our x1 and this is our x2, means at these two different points we are going to get same f of x, that is f of x1 is equal to f of x2. Even though our x1 and x2 are different here, but our range or the image of these 2 points are same. So clearly even the tan function, when it is defined like this, that is the domain is this one and range is set of real numbers, clearly tan function is not an 1 function. So it is not 1 means it is again not a bijective function. Now we need to turn this tan function into what? Into a bijective function, that is we need to turn this tan function into 1 function. That can be done by restricting the domain. So how we are restricting the domain? So that each value of the domain should get one and only one image. So suppose if I restrict from 0 to pi by 2, whether it is possible, or if I restrict from 0 to pi, how it will be the graph. So you need to think in all different ways. So suppose if I restrict from 0 to pi by 2 means you can see here we are going to get only this much of the graph, but we are not going to get the, since the function is onto and the set of real numbers is considered as the range of the tan function, negative value of those is not at all having the values, means clearly it does not becomes an onto function. But the tan function is onto, but we need to prove it 1 1. So while taking 0 to pi by 2, it does not satisfy the onto condition, so we need to think further. So suppose if I restrict the function from minus pi by 2 to pi by 2, at that time what we are going to get? We are going to get only this much as the graph from minus pi by 2 to pi by 2. So if this much is a graph means if I take any value of x from the domain, that is from minus pi by 2 to pi by 2, we are going to get one and only one image in the range, that is in this from the set of real numbers for each value lying between minus pi by 2 to pi by 2. So when the tan function's domain is restricted from minus pi by 2 to pi by 2 and the range is set of real numbers only, at that time the tan function has become the 1 1 function, and clearly the tan function was onto also. At that time it became what? Bijective function. So now the tan function became bijective function, means clearly there exists a inverse of this function, that is tan inverse, which is lying from set of real numbers, tan inverse whose domain is set of real numbers to the range, that is minus pi by 2 to pi by 2. So not only in the range minus pi by 2 pi by 2, suppose if I restrict the domain from pi by 2 to 3 pi by 2 to 3 pi by 2 also, means at that time we are going to get this one as the graph. So at this time also what the function is going to become, the tan function is going to become the bijective function. Suppose 3 pi by 2 5 pi by 2 means also the function or tan function is going to become a bijective. Suppose minus 3 pi by 2 to minus pi by 2 also means the function is going to become a what? Bijective function. So this range, that is minus pi by 2 to pi by 2 of a tan inverse of the tan function, this range is called as the principal value branch of the inverse of the tan function, and rest of the branch, that is as I said, suppose if I restrict from pi by 2 to 3 pi by 2, or from 3 pi by 2 to 5 pi by 2, or what, minus pi by 2 to minus 3 pi by 2. So all these becomes what? Different branches of tan inverse function, but this becomes the principal value branch of tan inverse function. So tan inverse function, it is defined from set of real numbers to the principal value branch minus pi by 2 to pi by 2. So this is the inverse function defined, and this is how we are going to get the inverse of the tan function.